Last video this week, and I've saved the hardest thing for last. So if you've been watching videos for an hour or so, you know what? Maybe watch this one tomorrow. Give yourself a little break, go get a soda, do something, because this one's going to take some brain power. When you're ready, let's go ahead and watch this video talking about the fundamental theorem of algebra, which is another strategy for helping us find zeros when sometimes we have some imaginary zeros. Essentially, what the fundamental theorem of algebra tells us is that if we have a polynomial with complex coefficients, we're going to have at least one complex root. And it also tells us that if we have a complex root like a plus bi, and that's how we write the complex numbers, remember, something like 2 plus 3i, then we know that its conjugate is also a root. So if 2 plus 3i is one of our factors, or one of our roots, one of our answers, then 2 minus 3i is also one of our answers. So let's take a look at how this comes into play. And again, this one's going to hurt your brain a little bit, but we're going to power through. We're going to go through this question together, but let me just caution you again. If you've been watching videos for a while, this is not a video you want to watch when you're fatigued already. So if you're tired of math today, take a break for an hour or for a day and come back to it later. This one's going to hurt your brain a little bit because we're going to deal with some imaginary numbers, 1 minus 5i. That's going to be one of our zeros. And so as we can see, the division using imaginary numbers is something we haven't really done before. So we're kind of using what we learned in our last video, but now we're taking it to the next level because obviously in the real world, you don't always get nice, whole, pretty rational numbers. So what this tells me right now is that I have a zero of 1 minus 5i. And again, because the conjugate is also a zero, I have a zero of 1 plus 5i. And there might be more zeros, but we'll find out. And the way that we find out is I'm first going to have to divide this polynomial by this and by its conjugate. That's the part that's really going to suck. So again, we're going to start going through this together. I'll go as slowly as I can. It is difficult. So what I want to do is I want to take this, which is a zero, just as I did before, and stick it inside the box for my synthetic division. Then I'm going to write my coefficients of 1, of negative 3, of positive 28, and of negative 26. And my hope is that I get a 0 right here because it tells me given that's a 0, which means I should get a remainder of 0 unless I screw up when I'm doing the math, which is possible. So how do I do this? I do it just like I normally do, but obviously it's going to be more difficult because I have imaginaries. So I'm going to use a different color here. Let's bring down the 1, as we always do. And here's where it's going to start to get tricky, because now I have to take 1 times 1 minus 5i. Well, that one's not so bad because I get 1 minus 5i. And then I'm going to add 1 minus 5i to 3, negative 3. So negative 3 plus 1 is negative 2. And then I don't have any I to add it to, so it's minus 5i. Well, now what? This is the part that really sucks, because this needs to be taken times this. So again, get your scratch paper out. You're going to be using it a lot. I'm going to take negative 2 minus 5i, and I'm going to FOIL it with 1 minus 5i. So negative 2 times 1, negative 2 times negative 5i is plus 10i. Negative 5i times 1, negative 5i. I'm just foiling. Negative 5i times negative 5i is positive 25i squared. Please remember that I squared is equivalent to negative 1. So what I have now is I have negative 2. I've got these guys that I'm combining together to get plus 5i. And then this guy at the end is actually 25 times negative 1. So negative 25. So that leaves me with negative 27 plus 5i. That's what's going to go here. And again, that's by foiling. Now let's add, because remember, everything above the line we add. 28 plus negative 27 is 1. I still have my plus 5i that I can't combine with anything, so that's what I get, 1 plus 5i. Now, just as before, I have to FOIL. 1 plus 5i, I have to take it times 1 minus 5i because that's what's over here. And I'm going to FOIL. 1 times 1 is 1. 1 times minus 5i, positive 5i times 1. And then 5i times negative 5i is negative 25i squared. Just like last time, I'm going to combine these two. These two actually end up canceling out because they were conjugates. And I get negative 25 times negative 1, which is positive 25. So my answer is 26. So 26 goes here, and look at that. We got a remainder of 0. So you might have thought, well, good, that wasn't horrible, or maybe you thought it was horrible. It might get a little bit worse, so I'm sorry about that, because now what I have to do is I have to take the conjugate, 1 plus 5i, and take this stuff and divide it by that. So I'm going to take 1 and negative 2 minus 5i and 1 plus 5i. So I'm just recopying what I had before. And again, this should end up being 0 because we know that if this is a factor or a 0, then the conjugate also is. So now I'm going to just do my work again. My work says bring the 1 straight down, multiply 1 by 1 plus 5i, which is 1 plus 5i. If I add those together, negative 2 plus 1 is negative 1, minus 5i and plus 5i cancel, so it's just negative 1. Then I'm going to take negative 1 times 1 plus 5i, which gives me 1 plus 5i, but negative, because I took it all times a negative. And so these two are opposites and end up canceling to give me 0. So what do I have left over now? I have, because I started at 3, and this would be x squared, an x and a constant, so this is just x and a constant. So my answer that's left over is x minus 1. So I'm looking for all of the factors and all of the zeros. Well, this is a factor, so my factors are x minus my first answer, which is 1 minus 5i, and don't feel like you have to make that better than that. That's my answer for my first factor. My second factor is x minus 1 plus 5i. Do make sure that it's in parentheses or it's wrong. And then this factor is left over, x minus 1. What are my zeros? Well, I already had those first two zeros. What's the 0 for x minus 1? Well, set x minus 1 equal to 0 and get 1. So my last answer is 1. So there are my zeros. 2 of them are imaginary. The other one is obviously a rational number. Just one more, I promise. If you don't want to do this one on your own, I don't blame you. You can just work through it with me. But if you're feeling up to a challenge, press pause, do this question, then press play to see how you did. So again, I'm already given, I'm going to write my zeros up here. Again, I know 1 plus 5i is a 0, and I also know that 1 minus 5i is a 0. And if I want to keep track of my factors, that would be x minus 1 plus 5i, and then x minus 1 minus 5i. And now I just need to see what's left over, just like I did last time. So let's get cracking. I will start by putting 1 plus 5i inside the box. I'm going to use 1, which is x to the 4th. X to the 3rd is negative 2. X squared is 28. X to the 1st is negative 4. x to the 0 is 52. Make sure you get those signs right. Again, because we're given it's a factor, we should end up with 0. So let's see how we do. Bring down the 1. Take 1 times 1 plus 5i, so 1 plus 5i. Add negative 2 to 1 plus 5i, giving me negative 1 plus 5i. And now I'm going to have to FOIL negative 1 plus 5i multiplied by what's in the box, which is 1 plus 5i. That gives me negative 1 minus 5i plus 5i plus 25i squared. So remember, this is essentially going to be 25 times negative 1, so this is actually negative 25. Combine like terms, these babies go away. I get negative 1 minus 25, or negative 26. That goes here. Add those together. 28 and negative 26 gives me 2. 2 times 1 plus 5i means 2 times 1, and 2 times 5i. Then I'm adding. Negative 4 plus 2 is negative 2, and then plus 10i. And now I have to take negative 2 plus 10i and multiply that by, again, what's in the box, 1 plus 5i. So now I'm FOILing again. Negative 2 times 1, negative 2 times 5i, 10i times 1, and 10i times 5i, 50i squared, which is really negative 50 because I squared is negative 1. If I combine terms, my negative 10 and positive 10i cancel. Negative 2 minus 50 is negative 52. Put that here, and that gives me my remainder of 0. So I feel pretty good about myself so far because I got that 0. Now I have to do the same thing again. I'm going to take 1 minus 5i, which is the conjugate, that second one, and I'm going to use everything here and just bring it down. So 1, negative 1 plus 5i, 2, negative 2 plus 10i, leave a space. Remember, this should end up being 0. So now let's do it again. Bring down the 1. 1 times 1 minus 5i is 1 minus 5i. Negative 1 plus 1 canceled. 5i and negative 5i canceled. I get a 0. Take 1 minus 5i times 0 to get 0. Add 2 plus 0 to get 2. Take 2 times 1 minus 5i, so 2 times 1 is 2. 2 times minus 5i is minus 10i, and I do get my remainder of 0. So my factors so far are x minus the quantity of 1 plus 5i and x minus the quantity of 1 minus 5i. What's left here? Well, if we started at 4, this would be x to the third. That means this is x squared. So this is x squared plus 2 is a factor. Now, then the question is, can we continue to factor x squared plus 2? Well, no, we can't because it's a plus. So if it was a minus, I could maybe keep going, but my factors then are the 2 that I've already listed, and then x squared plus 2 is all that's left over. Now, to find my zeros, I've already found my first 2 zeros. My last 0 is found by taking x squared plus 2 and setting it equal to 0. I couldn't factor it any further, so I'm just going to solve from here. To solve, I'm going to subtract 2. And it's okay that I get an imaginary number because I'm just trying to find all of the zeros, and imaginary numbers can be zeros. If I take the square root of each side, I get x equals plus or minus, and then this is I radical 2. So what are my other 2 zeros? Is positive I radical 2 and negative I radical 2. So there's my zeros, and then of course here are all of my factors.